So, okay, day one, we talked about simplifying these. I think you guys are getting faster and faster with that, so that's great. We talked about multiplying them. There were some tricky ones. We talked yesterday about solving for x by taking square roots on both sides, right? And that, I think, went really quickly. So today, what we're going to talk about is actually like the operation. So we're going to do adding, subtracting, and multiplying complex numbers. We will do division in its own day because unfortunately division has the problem. Do you guys remember that you're not allowed to have a square root in the bottom of a fraction? Yeah, a complex number is technically a square root, so we have to talk about like rationalizing the denominator. We'll do that tomorrow though. So the big part to remember today is that front page. Remember where I said I is I squared is -1, I to the third is -I to the fourth is 1. Honestly, the big one you need to remember today is that I squared is -1, because that's going to come up again and again and again today when we multiply. So let's talk about complex numbers. We talked about pure imaginary numbers. So now when we're talking about a complex number, and I'm going to highlight here, complex number is any number that can be written in the form a plus bi or a minus bi, where a and b are the real numbers, so they're just like the normal looking numbers, and then the bi is that imaginary part. So to start, let's talk about adding and subtracting. I do have a typo. If you can see, example C is example C from the other example, so we have to change that. So if you can cross off example C, I'm full of mistakes. This should be 2 plus I minus 3 minus 5i. That looks better. Okay, so if you remember adding and subtracting polynomials at all, this is really the same thing. If you have a plus here, you can really just drop the parentheses, and you can just think of this as 7 plus 4, right? That's the real part, plus I plus 4i. So what is 7 plus 4? 11. And what's I plus 4i? 5i. And that is it. That's all adding and subtracting. It's just like polynomials. You treat the I like it's an X, basically. I don't even know that there's a tricky part here. It's just adding like terms. You should never have a power on an I when you're adding or subtracting, because we're not like increasing powers at all, because we're not multiplying them. It's pretty straightforward. So if you look at part B without me really doing anything, what's the answer here? 7 plus 6i. There is one little caveat here. The complex number, so the complex number being a real number plus or minus an imaginary part, complex number has to be where the order is real plus or minus imaginary part. Okay, so if you put 6i plus 7 in Go Formative, it'll mark it wrong. I probably wouldn't care on a quiz or test, but this is the convention again, okay? All right, subtraction's a little bit trickier, because what we need to do to start is we actually need to distribute in this minus and then drop the parentheses. So you can make this, you take the first one just as is, so we have 2 plus I, but then this becomes minus 3, and then a negative and a negative makes that a positive 5i. You all good with me distributing that negative? Just watch out for those. So what's 2 minus 3? -1. And what's I plus 5i? 6i. So -1 plus 6i. All right, so adding and subtracting, what do we think?
I thought you said it was going to be a tricky part. I thought it was going to be some tricky part.
Tricky relative to what we're doing. All right, so addition and subtraction, you're not multiplying your i's, powers are not increasing, nothing like that. Multiplication is where we start to see the I squared, okay? So multiplication, we do have to use our distribution property here, and we'll have to be careful about order. So I'm going to multiply in this 4i to both parts. All right, so 4i times negative 2 would be negative 8i. What's 4i times 8i? 32 I squared. Okay, now here's the tricky part. What is I squared equal to? Negative 1. You cannot leave an I squared. You can only have I. No I's with powers. Okay? So you have to take a step and do a substitution where you make this a 32 times a negative 1. You guys will get quicker at this. You will start to just switch your sign on this and just drop the I altogether. Don't do that until you feel comfortable with it. But our final answer in the correct order, 32 times negative 1 is negative 32 minus 8i. So you'll have to rearrange here order-wise sometimes. And you have to watch that I squared.
So wait, is it 32i where when it's like 2i being distributed?
2 i's being multiplied,
So
yes.
this becomes a square.
So then it'll become a square
Okay.
because I times I is I squared. And so then it just becomes negative 1. So really you just change the sign on that coefficient, but then you need to remember to drop the I completely.
Okay.
Part B, I'm just distributing a normal number. So it'd be 2 times 2 is 4 plus 10i. As long as there's no I squared or I third or I fourth or I whatever, you're good. It's in the correct order. It has a real part plus the imaginary part. How would you guys like to multiply part C? What do we do when we multiply a binomial times a binomial? First number multiplied by the second parentheses. Okay, so you're talking about the distribution method, which is my personal favorite. There is another one. Starts with an F. FOIL. I don't care how you do it. If you are comfortable with FOIL, that's fine. That's where you multiply the first terms, the outside terms, the inside terms, the last terms. Do you guys remember doing that? So it'd be like first, outside, inside, last. That's FOIL. So I'm going to like split this in half. Can I split it in half? I'll do it twice maybe. I personally like the distribution method. That's where you just take the first term times the second parenthesis, and then the second term times the second parenthesis. I'll show both just again because it's been a little while. So FOIL up here, this FOIL. So it'd be 4 times 3 is 12. 4 times negative 2i is negative 8i. 2i times 3 is plus 6i. And then 2i times negative 2i is negative 4i squared. So then you can combine your inside terms. So we have 12. Negative 8i plus 6i would be minus 2i. And then this is the same as minus 4 times negative 1. Which, what's negative 4 times negative 1? Positive 4. So if this was a positive 4 plus 12, you end up with 16 minus 2i. That's solving using FOIL. Which again, if you're comfortable with FOIL, go for it. If you want to use the distribution method, you take this first number times this whole second parenthesis. So the setup would be 4 times 3 minus 2i. And then you'll take the second number times this whole second parenthesis. So plus 2i times 3 minus 2i. Distribute in both parts. So you still do the 4 times 3 is 12. 4 times negative 2i would be negative 8i. 2i times 3 would be plus 6i. And 2i times negative 2i is negative 4i squared. You can see we're actually at this step here. Right? It's the same exact layout. So then this would end up being 12 minus 2i times negative 4, or minus 4 times negative 1, which again, that becomes positive 4, so it'd be 16 minus 2i. I do not care which method you use. I think this one is more mathematically sound. You probably would want to use this second method if you have like a binomial times a trinomial, right? If it's not just a 2-term times a 2-term, if it's 2 terms times a 3-term, you definitely want to use this method. But I don't care how you do it. As long as you're not photomathing it, I'm happy. Questions?